Hello students, welcome to my channel Grey Physics. So today we are going to discuss about electric field and electric field intensity. So let's start the class. So the topic of today's lecture is electric field and electric field intensity. So in the last class we discussed about electric charge, and we also discussed about the Coulomb's law of electrostatic force, right? So today we are going to discuss a new topic called electric field. Okay, electric field. So what is the definition of electric field? An electric field is said to exist at a point if a force of electric origin is exerted on a stationary charged body placed at that origin. It means that if we consider a source charge like this, a source charge, positive source charge. What is this? This is a positive source charge. Suppose the value of the source charge is Q. As we already discussed in the first lecture of electric charge, that the electric charge is represented by a letter Q, small q or capital Q. Okay. So the source charge is plus Q. Okay, which is placed at point, suppose at point O. Okay, so it is assumed that the charge Q produces an electric field, means electrical environment in the surrounding space. If I draw this charge in a new slide, I mean, if this is the source charge plus Q, which is placed at the origin O, this positive charge Q will produce an electrical environment in the surrounding space. Okay, in the surrounding space, and this electrical environment is called as electric field. Okay, called electric field, and the exact definition can be written like this. Okay, so to test whether there is an electric field or not, what will we do? We will bring a very small test charge, a very small test charge. Suppose we bring a very small positive test charge, okay, Q naught. I mean, this test charge has been bring from somewhere like this, and it is placed here. Okay, so suppose this point is P. We place this test charge here at a point P. Okay, here at this point P. Okay, if a force F is exerted, on the positive charge on the test charge Q naught, okay, then we say that a electric field is present in this surrounding. Okay, now coming to the next point, what is electric field intensity? The electric field intensity or electric field strength at a given point is defined as the force experienced by a unit positive test charge placed at that point without disturbing the position of the source charge. Okay, and mathematically the electric field intensity or electric field strength E can be written as the ratio between the electrostatic force and the test charge. So if a source charge Q is placed at the origin O, and if we bring a test charge Q naught at point P, then we know that from the Coulomb's law a force F will be exerted on this test charge, which is given by 1 by 4 pi epsilon naught Q naught divided by R square R cap, if the distance between the center of the test charge, center of the source charge to the center of the test charge is small r, then we can write the electrostatic force experienced by this test charge is given by 1 by 4 pi epsilon naught Q naught by R square R cap. So according to the definition, the electric field strength E is defined as the force experienced by unit positive charge, unit positive test charge. This is test charge. Okay. So from if we just substitute the value of the force here, we can see that the expression for the electric field intensity can be written like this: 1 by 4 pi epsilon naught Q naught by R square R cap divided by Q naught. So this Q naught and this Q naught will be cancelled out, and we will get the electric field intensity, the expression of electric field intensity like this: 1 by 4 pi epsilon naught Q by R square R cap. So this is the mathematical expression. This is the mathematical expression of electric field intensity. Okay. So coming to the next point, the unit of electric field intensity, unit of electric field intensity. Okay. So the unit of electric field can be electric field intensity can be found from this relation F by Q naught. The unit of force F is Newton, as we all know that Newton, and the unit of charge is Coulomb, right? So Newton can be written like capital N, and this is Coulomb is capital C. So we can see that the unit of electric field intensity is Newton per Coulomb. Okay. So this is the unit. Okay. So if we want to find the dimension of electric field intensity, then we can simply do the dimension of force divided by dimension of charge. Okay. So as we all know that dimension of force is equal to mLt to the power minus 2 over the dimension of the charge. Okay. So sometimes some students get confused how to remember the dimension of force. You just remember the simple formula F is equal to ma, Newton's second law. From here you can see the unit of mass is kg, and unit of acceleration is meter per second square, right? So you then simply write the dimension of mass is m, dimension of length is L, and the dimension of time is t. So here it is square, so we write it square here. So coming to the next point, you just write the dimension of F, means the dimension of Newton. You can simply write ml T inverse square. So in this way we can remember the dimension of force. Okay, so coming to our main point, the dimension of electric field intensity E is mLT to the power minus 2 divided by dimension of the charge, right? So but this dimension of charge can be written like this, because we know that the current I is equal to charge q by time, right? From here you can see the charge q can be written as current I multiplied by time. So from here you can write the unit of current is ampere A and the time is t. So the dimension of charge, now charge q c, can be written as AT. So in this equation we will now substitute the value of dimension of charge like this, AT. Okay, so how it can be write, you see here, after simplification we can write mLT to the power minus 2 over AT, right? AT, dimension of C is just replace it by AT. So you get okay, so after simplification you just write in the same line mLT to the power minus 3 A inverse, right? Because you see T is now on, here it is T to the power minus 2, here on T, so it will go off and it will become T to the power minus 3. So this is the dimension of electric field intensity, right? So coming to the next point, so this is the expression, this is the dimension. So the next point is electric lines of force and its property. And electric lines of force can be defined as the curve along which a small positive charge would tend to move when free to do so in an electric field, and tangent to which at any point gives the direction of the electric field at that point. Okay, so the exact definition from the textbook is given here. If we just go through all the properties of the electric lines of force, we can see here few of the properties are mentioned like this. The lines of force are continuous smooth curve without any break. Then the lines of force start at positive charges and at the negative charges they can't form closed loop. So what does it mean? So if we take a positive charge here and a negative charge here, a positive charge here and a negative charge here, the electric lines of force generally originates from the positive charge and ends at the negative charge. Okay, so it will emit perpendicularly at the surface of the source. So it will just emit like this and it will enter to the negative charge like this. Okay, if we draw the electric lines of force, will look like this. Okay, it will just, so the directions are like this. It will emits from the positive charge and it will enters the negative charge. So this electric lines of force are smooth, okay, smooth and continuous. Okay, so the other properties are the tangent to the line of force at any point gives the direction of the electric field at that point. It means that if we draw a tangent, suppose if we consider a point here, okay, and if we draw a tangent here, this will give this will give the direction of electric field intensity. Any point, suppose here the tangent will be like this at this point, so this will be the direction of the electric field intensity. So next property is that no two lines of force cross each other. It means that we have here 1, 2, 3, 4, 5, 6, 7 electric lines of force, and we can see here that they are not crossing. It means that electric lines of force cannot be like this, it cannot be like this, because it is crossing these lines, so it can never cross any other electric lines of force. Okay, and the last property is that these are imaginary lines. Okay, so thank you very much.